Hi everyone, this is Joyce from creative-biolabs vaccine. Today, I will give you a brief introduction to the Nano Adjuvant. I hope what I provide can help you with your research. All my introduction includes the introduction of Nano Adjuvant, advantages, types, prospect of Nano Adjuvant, and our services. Nano Adjuvant is a kind of nanoparticles with size less than 1000 nanometers, which can enhance the immune response of the body to antigens or change the type of immune response. Compared with traditional adjuvants, nano adjuvants are favored by vaccine researchers because of their targeting, sustained release, safety, and high efficiency. In particular, it shows great advantages in immune adjuvant effect and safety, and promotes the wide application of many new vaccines in clinical practice. Adjuvants have been widely used in the preparation of vaccines. It helps the body produce a specific immune response to antagonizes. And the main roles as following. 1. Induce sustained immune response in children, the elderly, immune system deficiency, and other immunocompromised people. 2. Promote the infiltration of vaccine into cells and targeting antigen presentation cell, to induce cytokine release or enhance antigen presentation. 3. Increase the absorption of vaccine by gastric mucosa, and ingesting antigen through mucosa. 4. Reduce the dosage of immune substances, to the minimum threshold of the dose required for immune protection. 5. Improve the validity of antigen and enhance its immunogenicity, immune tolerance, and immune response speed. Nano-adjuvant has the characteristics of improving vaccine antigen stability, immunogenicity, and sustained release property. The abundant activation center on the surface of nano-adjuvant can make it bind to antigen stably, and as an efficient means of delivery, antigen can be targeted and transported. Nano-adjuvants can load antigens by encapsulation, passive absorption, or gene fusion, thereby forming a warehouse for antigens, to prevent enzymatic hydrolysis or hydrolysis. At the same time, some nano-adjuvants also have immunostimulatory effect, which can enhance the immune response by improving the presentation efficiency of APC. It was found that particle size was an important factor affecting vaccine transport and APC uptake in vivo. Nanoparticles with particle size less than 1000 nanometers were easily ingested by dendritic cells and macrophages, while particles with particle size less than 100 nanometers were more likely to come into contact with APC through lymphatic vessels. It has been proved that nanoadjuvants can induce strong humoral and cellular immunity, and can delay the release of antigens, thus continuously stimulating the body to produce high titers of antibodies. At present, nanoadjuvants are divided into three categories: inorganic nanoadjuvants, biomolecular nanoadjuvants, and new type nanoadjuvants. Calcium phosphate adjuvant is a kind of nanoparticles with particle size less than 1000 nanometers, prepared by coprecipitation and reverse microemulsion. It has good biocompatibility and safety, and can be used as an effective delivery vehicle to transport foreign genes into cells for antigen recognition. However, when calcium phosphate nanoparticles are used for gene transfection, it may lead to the integration of foreign genes into the host genome, and reduce the safety of the vaccine. Nanoaluminum hydroxide adjuvant is a kind of particle with a size of 4.5 nanometers times 2.2 nanometers times 10 nanometers, which is formed by the aggregation of small fiber particles. It is a nanoadjuvant formed by molecular modification on the basis of traditional aluminum adjuvant. The auxiliary effect of aluminum adjuvant on cellular immunity is not obvious, thus, it is only suitable as a vaccine antigen adjuvant with strong immunogenicity, or mass production. However, nanoaluminum adjuvant may sometimes cause slight inflammatory reaction at the injection site, which is related to its immunostimulatory effect. Liposome is a hollow vesicle structure encapsulated by one or more bilayer membranes, which has both adjuvant and carrier functions. It can promote the intake of antigen by APC, thus enhancing the immune effect. The use of liposomes as immune adjuvants has unparalleled advantages over other adjuvants. 1. Liposome as a carrier has the same immune effect as aluminum adjuvant. 2. Liposome carrier is mainly composed of lipids, which is easy to be biodegraded by the body, and can significantly reduce the probability of inflammatory reaction at the injection site. 3. Liposome as a carrier can encapsulate a large number of antigens, and has a strong repository effect. However, there are still some unsolved problems in liposomes as adjuvants. For example, in the process of encapsulating antigens, small liposomes tend to fuse into large liposomes, to form a stable state. While in the process of liposome fusion, it is easy to cause the loss of encapsulated antigen, thus affecting the immune effect. Virusomes, about 150 nanometers in diameter, is composed of circular monolayer vesicles, which is an empty shell structure without viral nucleic acid. Virusomes is composed of circular monolayer vesicles, which is an empty shell structure without viral nucleic acid. Virusome release system is a more advanced antigen delivery system developed on the basis of liposomes. It is generally believed that virusomes retain the spatial conformation of natural virus particles, and the antigenic epitopes neutralized antibodies. Virusomes can not only stimulate humoral immunity, but also stimulate cellular immunity and mucosal immunity. It can still induce a strong immune response in the absence of any adjuvants. Viroids belong to microorganisms, which may replicate themselves in sensitive hosts, causing the host to show some symptoms of infection. Therefore, genetic modification of viruses can reduce or prevent their replication in the host. Virus-like particles are empty shell structures with diameter in 20 to 200 nanometers, formed by self-assembly of one or more structural proteins. Because virus-like particles do not contain nucleic acid substances, they are not infectious and cannot be replicated in the body. Because of its natural virus-like structure, virus-like particles are easily bound to the molecular surface of MHCI and MHC2, and are identified by the APC, stimulating the body to produce a high level of humoral immunity and cellular immune response. In addition, the multivalence of virus-like particles enables B cells to recognize specific antigen receptors that can be effectively cross-linked and activated. However, the limitation of virus-like particles is the loadable length of foreign genes. When the number of amino acids in foreign genes exceeds 300, it will affect the self-assembly of virus-like particles into particle-like structure. This leads to the loss of the surface effect of virus-like particles, and the weakening of related immunostimulatory effects. Immunostimulating complex is a compound adjuvant which mixes antigen, cholesterol and plant saponin squalene at 1:1:1. It is a new antigen presentation system, which has the dual functions of adjuvant and antigen. In recent years, ISCOMS has been gradually used in clinical trials of HIV, HSV, HCV and cancer vaccines, and good immune effects have been obtained. While ISCOMS cannot form immune complexes with all the target antigens, it can only bind to immunogens containing more hydrophobic groups. However, the immunogen containing more hydrophilic groups is not suitable for the preparation of vaccine mixed with ISCOMS. MF59 is a kind of oil and water emulsion, which is formed by microfluidization of Charcan, 4.3%, tween 80, 0.5%, and sorbitol trileate span 85, 0.5%, under high pressure, and its average particle size is less than 250 nanometers. Clinical toxicological studies have shown that MF59 has no genetic toxicity, teratogenicity or sensitization, and other treatment-related safety issues. Only a very small number of volunteers have been confined to the injection site of inflammation response. Nano Adjuvant has been used in a variety of vaccine research and development, and has shown many advantages, such as safety, sustained release, and high-efficiency immune adjuvant, in a variety of animal model experiments. At the same time, nano adjuvants have the appropriate shape and size, which makes it easier to enter the draining lymph nodes, thus effectively recognized and presented by APC to induce specific immune response. In addition, since hydrophobic nanoadjuvants can induce a more efficient immune response than hydrophilic nanoadjuvants, the structure of hydrophilic nanoadjuvants can be optimized by physical and chemical methods to improve the antigen loading rate. With the further development of vaccinology and the in-depth study of the mechanism of nanoadjuvants, more nanoadjuvants will be found and used in human and animal vaccines. In terms of our extensive experience in delivery system development, creative-biolabs is proud to offer our clients a series of nanoparticles development for vaccine delivery, with the best quality and most competitive price. In addition, we can also provide one-stop vaccine services including but not limited to vaccine design, adjuvant selection, analytical development and qualification, vaccine preclinical assessment, vaccine formulation development, process development and GMP manufacturing.